This is called as Newton's Cradle. It is very special apparatus, wonderful teaching aid which gives the concept of momentum and energy conservation. The principle of conservation of momentum and the principle of conservation of energy are very important in the elastic collisions. We can understand that there are 5 metal balls in front, and if I displace one metal ball to some height, this has some potential energy, and when I leave it, it will come down like a pendulum and it will hit the 4 balls with some kinetic energy and momentum. We can see what happens when it will come and hit. Okay, we observe that the ball will come and hit the 4 balls. Only one ball will get kicked out because before collision and after collision the momentum and kinetic energy remains constant. So same amount of momentum is transferred from one ball to other ball and next, and finally one will get out. Now if I take 2 balls and leave them, we observe that 2 are coming out here, and that is again because of momentum and energy conservation. Now if I take 3 balls, we get the same result. Before collision 3 will come and hit, after collision 3 will go out, and that is the momentum and energy conservation. Now if I take 4 balls, we will observe the same thing. 4 will come and hit one ball, 4 will go away, 1 will remain back. You can see from this side also, it is the same thing. So these metal balls are very heavy, massive balls, and they are very tough, rigid, and they have some elastic property. And if I take, say, if I take 2 balls from one side and 1 from other side and leave them simultaneously, you can see what happens. You can see it again, observe it again. I am taking 2 and 1. You can easily observe this 1 to 2 exchange, and this 1 to 2 exchange is because of momentum and energy conservation. Now if I take 1 from this side and 1 from this side and allow them to fall simultaneously, I will observe that the middle 3 are not moving at all, and they are remaining almost at rest, and the 2 are colliding. Now the question arises, why the middle 3 are not moving? The reason is very simple. When there is F1 and F2, the 2 forces are acting simultaneously, and if these 2 forces equal and opposite, their net force is 0. So when resultant is 0, there is no external unbalanced force acting on the middle 3 balls, and that is Newton's first law of motion. We can say Newton's law, first law. We can observe that the body will remain in rest condition or will continue with same speed, same direction, unless and until it is acted upon by the external unbalanced force. So if there is no external unbalanced force acting, the body remains in stationary state. Yes, you can see this again. Now if I take 2 from this side and 2 from this side and allow them to fall simultaneously, again we observe that the middle one is almost stationary, and we have a perfect balance like this, and the middle is not moving because the 2 equal opposite forces will cancel each other. And if I make some balls disappear from the picture and only 2 are remaining in front, and I take 1 ball away and allow it to hit and collide, imagine what will happen. This will come and hit this ball, and after hitting this will stop and he will go ahead. Now question is why the ball comes and stops. The question is why the ball comes and stops. The reason, the answer is, this ball will come and hit this ball, and when it will hit, it will transfer all its momentum and all its kinetic energy to other ball. So there is transfer of momentum and transfer of energy from one ball to other ball, and this transfer is 100% because the two balls have equal mass, identical mass. Very interesting statement that if the two are having equal mass, then the momentum and energy transfer is 100%. If they are not equal, then the story will be different. One is light and one is heavy, so heavy will come and hit the light will go far away, and heavy will continue to move to some distance, and it is because of massive body. On the other hand, if there is one heavy mass and one light mass will come and hit heavy mass, the light mass will go back, that is called a rebound, and that is because of this action reaction. When something attacks one body, it will get back kick, recoil, and we can see here now a different story. Two are coming and hitting simultaneously, and they will keep on hitting for a long time, and that is because both are transferring momentum and energy to each other. See, this is different case, and the previous case was different. In previous case, one was at rest and other was hitting, and now both are coming and hitting, so they both will get recoil. It is like action reaction. They are having forces equal opposite, and both are transferring momentum and energy simultaneously. A very interesting case. Okay. Further things we can discuss, that if I have got two balls and one will come and hit, you can see that one will get out. Same thing from this side you can observe. And if one is stationary and two are hitting from both sides, the middle is not moving. Same principle again. Equal opposite forces like. And if three are there, and if before that, I will show you one more thing. If two are from one side and one from other side, and if I allow them to fall simultaneously, see what happens. Interesting. 1 to 2 1 exchange is there, and that is again because of momentum energy conservations. I can say now three balls are there and one is hitting, or say two are there and two are hitting, and if one is there and three are hitting, or if two from this side and two from this side, you can predict every event. What will happen after this collision? What will happen after this collision? There are plenty of events I can show. For example, I take 1 and 3 here, I get 3 1 1 3 exchange. Again, it is because of momentum energy conversion. And if two are coming from both sides, the two are remaining at rest. Every event is very interesting. So this whole apparatus is full of joy, we can say. It is called a multiple collision, and these collisions are very interesting. Multiple collisions are there, as if these balls are clapping for Sir Isaac Newton. Thank you.